Today we're going to be talking about section 2.1, which is on relations and functions. Now remember, a function is a relation when everything in the domain is paired with exactly one element in the range. Okay? So the way I like to think of functions versus relations is this. Okay? I like to think of it kind of like the mail. So let's say I have a little letter right here. Okay? This is my domain value, or my x value, like my letter. And then over here, I have my mailbox, which is kind of like my range. Okay? Letters go to the mailboxes. Okay? Now the thing you can remember is this. Okay? You can have one letter go into your mailbox. You can have a second letter go into your mailbox. Okay? You can open up your mailbox and you can see lots and lots of different letters in your one mailbox. Okay? However, what you never see is one letter in the domain, okay? One letter going to two different mailboxes. Okay? So let's say Grandma and Grandpa are writing you a birthday card, okay? And they decide to rip it in half and they send you part of it and they send your cousin part of it across town. Okay? Never happens that you have one birthday card going to two different mailboxes, right? So the way we think of that is using terms like one-to-one and on-to. One-to-one would say this, okay? Three different elements in the domain, okay? Each one of those pairs with exactly one unique element in the range, okay? So three little letters right here going to three different mailboxes. Now notice all the mailboxes in town don't get a letter, but each one of the letters that you had goes to its own mailbox. An onto function says this. Four different letters by the mail carrier, and they go to three different mailboxes. Okay, so you'll see that 3 and 4 right here both go to the same value C in the range. Okay, and that's okay. That's an onto function. But what we want most of the time in our functions is a one-to-one and onto function, where there are four unique elements, one more in your domain, and they go to four unique elements in the range. 4 birthday cards going to 4 different mailboxes. So let's look at some examples. Here's the first one. It says state the domain and range of each relation, then determine whether it's a function. Okay? So domain is always my x values. So in this case, -6, -5, -3, -1, and 6. Okay, so I'm going to write those down. Okay? And I like to put them in this kind of mapping way of writing it so that I can see it a little bit better. Okay? And then I go to my range. -1, -9, -7, 7, and then I have -9 again. So I don't need to write that one down. Okay? -1, -9, -7, 7, and we've already written -9. Okay? So the question is this a function? And the answer to that is yes, it is a function because each element in the domain is paired with one element in the range. So you think about it, I got 5 birthday cards, okay, and going to 4 different mailboxes. Okay, that makes sense. One of those is going to go to 2 of those letters is going to go to one mailbox. Right? So that is a function. This is a function. Now the question is it one-to-one, onto, both, or neither? Well, you'll see that since I have 5 elements in the range and I have 5 elements in the domain and 4 in the range, it can't be one-to-one. And that's also true because -5 goes to -9, as does 6. Okay, so it's not one-to-one. Is it onto? Meaning, is everything in the range going to get at least one thing from the domain? And that is true. So this is going to be an onto function. Okay? Function because every element in the domain goes to something in the range. Onto because all of the range values get at least one domain. Let's look at letter B. Okay? Let's put down our domain. 2, -1, -2, -1, and 2 again. So I have 3 elements in the domain. Now I go to the range. Okay? -2, -1, 0, 1, and 2. Now I should be rather suspicious because I only have 3 elements in the domain and I have 5 in the range. So if you think about it, this 2 is going to go to -2 and this 2 is going to go to +2. So this is your one little birthday card, okay, that Grandma and Grandpa are going to make for you, but they're going to split it in half and send it to you and going to send it to your cousin on the other side of town. Okay? Feel kind of gypped. This right here is not a function. So I don't even have to think about if it's onto or one-to-one because it's not a function. It's just a relation. Here's a couple examples that you can try as well. Now there are two different types of relations. There's discrete relations, which is like graph A, where it's like a certain number of finite points. Or there's continuous relations, like graph B, where it's a line. Okay? And we can tell the difference, whether continuous or discrete, by looking at their graphs. Now, if we want to figure out if something is a function or not, we use what's called the vertical line test. And that's where you draw a bunch of vertical lines. And when you do that, it should only go through one point at a time. Each vertical line should only go through one point. If it goes through more than one point, it's not a function. So here, if you look at right here, okay, if I look at this one right here, if I drew a bunch of vertical lines on this parabola right here, you'll see that it crosses my graph only at one point at a time. So this right here would be a function. However, in the other example over here, you'll see if I draw this green line right here, my line hits this point and this point. 2 points at one time. This is not a function. See the difference? Now in example 2, it says the graph shows the length of the Tour de France in kilometers each year from 2000 to 2009. Is the relation discrete or continuous? And does it represent a function? So if I look over here, it's just a bunch of random points. Notice it's not a straight line. There's not an infinite number of values in between them. So this right here is going to be discrete. Okay? Now the next question is it a function? Now if I drew a bunch of vertical lines along this, through my points, each discrete point, you'll see that it only hits at one point. So this is a function. However, it is discrete and not continuous. There's a guided practice problem on the bottom you could try as well. Example 3, graphing a relation. It says graph y equals 1/2 x minus 3 and determine the domain and range. Then determine whether the equation is a function. If it's one-to-one, onto, both, or neither, then state whether it is discrete or continuous. So lots of questions need to be answered here. Alright? So I always like to graph the exact same way. I make an x and y table, and I pick 5 values for x, and generally I like to pick the same 5 values, -2, -1, 0, 1, and 2. And once I know those, I put those values into my calculator, and I'll actually pump out 5 values for y. Now after putting these values into my calculator, I find that I get -4, -3.5, -3, -2.5, and -2. Okay? So once I put those values into my calculator, I get those 5 values for y. And now I'm going to graph them. So -2, -4 is going to be right here. Then I get -1, -3.5, 0, -3, 1, -2.5, and 2, -2. And it makes a straight line because I could put in a -1.5, or I could put in a 0.25, or whatever. And it makes a straight line. In fact, I could graph this on my calculator to see what it's going to look like. Okay, so that answers one of our questions. Is this discrete or continuous? Well, this is a continuous function. Now we know it's a function because everything in the domain, the -2, -1, 0, 1, and 2, all has its own unique thing for y, -4, -3.5, -3, -2.5, and -2. It's also one-to-one. I have 5 elements in the domain, 5 in the range. And it's also onto because there's no value in my y that I have 2 variables of x going into. So this is both one-to-one and onto. Okay? So it's a continuous function. It's both one-to-one and it's onto. Here's another one that you can try also. Now we have a couple different things. We have independent and dependent variable. Now, the book is probably going to try and give you a really hard definition of each one. But it goes like this. Independent variables are my x. I can pick any value for x. Dependent is my y variable. And the reason that's dependent is because my answer, my y, depends on what I put in for x. And then the last thing we want to talk about is function notation. So instead of writing y equals 2x minus 1, what we would say is a function of x is equal to 2x minus 1. So whatever I put in for x right here, I put in for x right here. So in this example, they have f of negative 6 is equal to 5 times negative 6 minus 1. That's function notation. So if I look at this one right here, example 4, it says to evaluate the function in function notation. So f of x equals negative 2x squared minus 8. So all I'm going to be doing then is f of 6 is equal to 2, and then where there was an x, I put in 6 squared minus 8. So I multiply 6 squared first is 36 times 2 is 72. So this is really saying 72 minus 8. And 72 minus 8 is going to be 64. So f of 6 is equal to 64. So you'll notice I put in a number for x, and I get a number out for my function of x. Now in letter B, it's a little bit different. In this one, I have f of 2y. So where there was an x, I'm putting in 2y. Okay? And so 2y squared is really going to be 4y squared. How did I get that? Well, I squared 2y. Okay? Now I multiply it by 2 is 8y squared minus 8. And you'll notice I can't simplify that any farther. So that means that my function of 2y is equal to 8y squared minus 8. So again, I put in a variable now this time, and my answer has a variable in it. On the bottom, you'll see 2 more guided practice problems that you can try.